Alright guys, I'm making this video to help you with your next part of the project where you do the transformations. If this will work. Okay. So I have my own little anchor project here. It's small. There's only 3 parts. Okay, so this is my original function in black, and I'm going to apply the first 2 transformations that would be in my project. So the most important things that you need to know about doing these successfully is that remember that if you have a transformation that's affecting the graph vertically, that it is affecting the y values and that it applies to the whole function, right? So I have my original function and I need to apply my transformation to the whole function. Probably the best way to be successful with this is to use parentheses around my whole function. If it's applying to the graph horizontally, then you need to apply the transformation directly to the x. So whatever the transformation is, it affects the x directly, and then other parts of the function then affect the x. Okay, so let's see what that looks like. So I have my black function as my original, my green function is the transformation, but I haven't applied the transformations yet. So the first thing when I look at this is I see there's a negative outside of the f of x. We have negative f of 2x. Okay, so that negative outside is going to affect the graph vertically. That means that I need to apply a negative to this whole function here. Okay, so I could either put a negative here and then here, or I can put parentheses, because remember parentheses is determines order of how things are applied to your function. So we'll go to the end. My function is going to be a little tedious because it's hard to do this on an iPad and record. But hopefully I'll get through it. All right, there, and now I'm going to put a negative out front, and there we go. We can see that my little piece there reflected vertically. Okay, for this one, right, you can choose, you don't really need parentheses because your whole function is x squared, and you need to have it needs to be x squared, and then you apply the negative, right? That would be different than putting parentheses around the x and putting negative x and then squaring it with the negative inside the parentheses. So you could do it with or without parentheses. You're going to end up with the same result, but if you just want to be consistent and put parentheses around your whole function so that way you know you won't mess it up, then do that. Okay, to give you an example again, I could put parentheses, right? This one's pretty much like this one. But I could put parentheses around this whole thing, or I just need to remember to apply it to the whole thing. So for instance, I could put a negative out here, and do you see how it's not where I want it to be? That's because it needs to also be applied here. Okay, so you can choose how to do it, but if you're not getting the results you want, I would use parentheses to see if that helps. All right, so I have my vertical reflection. Now I want to deal with this 2 here, and remember when it's on the inside, it's affecting the function horizontally, and it is a compression, a horizontal compression by a factor of 1/2. Okay, and it's going to affect the x directly. Okay, so again, I would apply it directly to the x, and I would use parentheses if you're not getting what you're expecting. Use parentheses. Put in 0.5 instead of 2. All right, we need to put in 2, even though it's a factor by 1/2, we do need to have 2 in there. Okay, there we go. Just double check my work here. All right, I applied the horizontal compression directly to the x by putting in a 2. Remember, it's the opposite, so I'm compressing it by 1/2. All right, coming down here, if I put a 2 right there, then it is stretching it vertically. That's not what I want. Okay, there is a difference. It can look a little bit the same, but is a difference between stretching it vertically and compressing it horizontally. So I'm going to put my parentheses right around my x. There we go. Hopefully you saw how the graph changed there. So now it's saying 2 times x, then times a negative, then squaring it. Okay, parentheses are used to force operations in a certain way. All right, so let's come down here, do the last compression. And there we go. All right, now you can see that I have a problem because it's not matching up the way I want it to, right? And I do want it to match up. So the issue here is that I changed the x values, right? The y values I changed in that everything that was positive became negative. If I had a negative, it would become positive, right? Since I'm showing my whole range, that's not a problem. The problem occurs with a piecewise function because remember, with the piecewise function, we have just a certain domain of the function that we're showing, right? For this, I'm only showing from -10 to -4, right? -10 to -4, okay? So when I go and change my x's, I have to change my domain as well. So I put a 2 in here. It shrunk it horizontally by a factor of 1/2. So in order to get my domain to work with this new function, I need to do the same to these numbers here, to these values. But remember, what actually happens to each x is they become smaller, right? So let me write this out for you, right? If I have x, y on my original function, then when I change it to, I'm just going to focus in on, well, I'll do the whole thing. When I change it to this, that means all my y's become negative and all my x's become half, right? Half x. So here on my domain, I need to go ahead and divide 10 by 2 and 4 by 2. Okay, then I need to do the same with my quadratic function, 4 by 2. There we go. And right here. All right. Now, have I flipped it and compressed it horizontally? I have. And it looks like the function, right? By changing my domain, everything's hooking up the way I expect it to. All right, there's something else I want to show you. Okay, for this next one, if I have my original function, gives me the values x, y, right? Then my new function, well, what's happening here is nothing's happening to the function vertically, but we are seeing a horizontal reflection and we're seeing a stretch by 2. So this would be -2x, y. Okay, so I come in here. Turn this one on. Turn this one off. We can see the function now overlaid in red. All right, so to apply the negative, it has to be on the inside directly to the x. So again, the way to keep track of this, and you can simplify your equations later if you like, is to just apply parentheses directly to the x. So that way you know you'll get what you want there. And I have another negative. And then I'm going to close my parentheses. And then I also need to apply a 1/2 directly to the x. I'm just going to go 0.5 because it's easier for me to type. Okay, directly to the x. And make it negative. And one more time, directly to the x. Close my parentheses right after the x. There we go. All right. Again, I have an issue over here, right? I'm not seeing my whole function, and that's going to be frustrating if you don't know what to look for. So the issue is, again, I applied some stuff to my x's, and I'm not seeing my function. It's because I need to change my domain. Okay, so everything's going to be, all the x's are going to be twice as big. That means I need to make all these twice as big. 20. This will be, actually, yeah, this will be 8. Okay, but also my signs changed, right? So I have to make that positive and make that positive. But now if you look, this doesn't make sense, right? I can't have 8, a value that's less than 8 but greater than 20. So not only do I have to remove my negative signs or make my positives negative or my negatives positive, I now have to flip the inequalities, right? Just like when you're solving inequalities. Okay, finally getting to where it kind of makes sense, right? That makes sense that it should be up there. I am flipping it horizontally, so that's not going to look very different. But I applied a horizontal stretch by 2, right? The opposite of what I see here. 1/2 means I need to find the reciprocal, or horizontal stretch by 2. All right, so that one looks like it's probably on the right track there. Let's deal with the quadratic here. So I need to make both of these bigger, twice as big. There we go. Now, because this is symmetrical, right, has even symmetry, it's still from -8 to 8. So I could change these just to be more accurate, but it's going to show me the right function here, right, because it's just reflected right here. But to do this accurately, you would actually change the signs on each of these 8s and then have to change the inequalities as well. All right. This next one, I'm going to make this 8. Well, I'm going to take care of the negative as well. So 8. I'll do this first. Okay, so I still don't see it because I need to change that negative. Let's look at this graph here just a second. Right, I made these bigger, but right now, this is this piece, right, being reflected over here. But my domain says, show me from 8 to 20, right? Well, the problem with that is that all occurs over here. I need -20 to -8. Flip my signs. There we go. All right, I've got what I want. All right, so to sum it up, I know it's kind of long. I'm not feeling that well, so it's a little hard for me to think and put this all together. But to sum it up, make sure that when you apply something to the x values, if you change your graph horizontally, you need to change your domains. That's why you're not seeing it if you're not seeing it or if it's not looking right. And if you're applying something vertically, you don't need to change your domains, but make sure you put parentheses around the whole thing, your whole original function, and then apply that transformation. Okay? If when it's a horizontal, just put the parentheses right around the x and apply that transformation. All right, I hope that helps.